So let's just see how we can implement the stack using the linked list. So as we know, in a linked list, we have multiple nodes and the nodes are connected using the link. And each node has the data and the link to the next node. So this is a single node building block of the linked list. Now we can define the node using a structure. So we use the struct node, and inside the structure we have the data and the node type pointer. We're gonna call this next. So this pointer will point to the next node in our linked list. And also because we are implementing the stack, so we need one pointer which will point to the top of the stack. So for that we're gonna use one node type pointer, and this will initially point to null. So let's now see how we can implement all of the different stack operations using linked list. So first of all, let's just see how we can implement the push operation. So push operation means adding one element into our stack. So initially our top pointer is pointing to null and our stack is empty. So here is a function to push item into our stack. So as a parameter we're gonna pass the value that we wanted to push into our stack. So first of all, we're gonna create one new node and we're gonna use the malloc to allocate memory for a single node. So that means we are allocating memory for a single node. And after that we're gonna check if the new node is null. That means if the memory allocation fails, in that case we're gonna say stack overflow. That means there is no more memory left to allocate for the new node. So in that case we're gonna simply return. So otherwise, if the memory allocation is successful, in that case we're gonna store the value into our new node. So the value that we have passed as a parameter, that will be stored into our node. Like in example, the value 1. So the value 1 will be stored into our new node, and then we're gonna update the new node's next pointer and it will point to the top. So as the top pointer is pointing to null, so that means this new node's next pointer will point to null. And then we're gonna update the top pointer, so the top pointer will point to this new node. That means our top pointer will point to this newly created node. And then we're gonna print the push is successful. So that means we have successfully pushed the value onto our stack. Similarly, if we call the push function with the value 2, in that case we're gonna repeat the same process. So that means first of all we're gonna create one new node, and then inside the new node we're gonna store this value 2, and after that we're gonna update this next pointer. So this next pointer will point to the top. That means this new node's next pointer will point to this top node. And then we're gonna update the top. So this top pointer will be updated to point to this newly created node. And you can see our linked list is updated and this new value 2 is pushed into our stack. So this way we can push another value 3. So that means a new node will be created with the value 3, and the next pointer will point to this top node, and the top pointer will be updated to point to this new node. And this way we can push multiple items into our stack. So let's now see how we can implement the pop operation. Pop operations means removing one element from the top of the stack and returning its value. So here is the function to implement the pop operation. So first of all we're gonna check, so if the top is pointing to null, so that means if the top pointer is pointing to null, that means our stack is empty. So in that case we're gonna print stack is empty and then we're gonna return. Otherwise, if the stack is not empty, we have multiple elements in the stack. So in that case, first of all we're gonna create one temporary pointer which will point to the top node. So that means we're gonna use one temporary pointer which will point to this top node, and after that we're gonna extract the value from the temporary pointer and we're gonna store into one variable popped. So that means we are having one variable popped which will having this data 3, and after that we're gonna update the top. So the top will be shifted to the next node. That means this top pointer will be shifted to the next node, and then we can free this temporary pointer. That means we're gonna free this temporary node. That means it will be deleted from the list, and then we can return the popped value. That means we're gonna return this value. So you can see after this pop operation, the first node is removed and we are returning the value of that node. So if we call the function pop, it will return this value 3. And again, if we call the function again, so again the same process will be repeated. That means we're going to use one temporary pointer which will point to this top node, and then the value of this top pointer will be extracted, and then top will be shifted to the next node, and then we're going to free the memory of this node. So that node will be removed, and then we're going to return this popped value. The function will return the value 2. So this way the pop function will remove the topmost element and it will return its value. So let's now see how we can implement the pick operation. Pick operation means it will return the top element from the stack without removing the element. So here we have the stack. So whenever we perform the pick operation, it will return the value of this top node without removing the node. So here is the function. So first of all, we're gonna check whether the stack is empty or not. So if the top is pointing to null, so in that case our stack is empty. So we're gonna print stack is empty and then we're gonna return. Otherwise, if the stack is not empty, we have multiple nodes. In that case, we're gonna return top data. Top data means this value. If we call the pick function, so it will return the value of this top node. It will return 3. And also we can implement isEmpty function. So this function used to check whether a stack is empty or not. So in this function, we're simply going to check if the top is pointing to null, that means the stack is empty. Otherwise, the stack is not empty. So this way we can implement all of the stack operations using one linked list. Now there are certain advantages and disadvantages while using the linked list. So first of all, let's just talk about the advantages. So here, because we are using the linked list, so here we have the advantage of dynamic size. So we do not need to specify any predefined stack size, because here we can allocate the memory whenever it's required. And because of this, here no memory is wasted, so we can very efficiently perform all the array operations. And also it has some disadvantages. So first of all, we require extra memory. So here in the linked list, we require extra memory for the next pointer of each node. And also secondly, here we have the slower access. So because the linked list nodes are scattered in the memory, so accessing them takes some time. So it is slower than the array. And thirdly, because we are using the linked list, so implementing the linked list is a little complex. And also here we have the risk of memory leak. So if we forget to free the memory of the unused node, in that case it can lead to memory leak. So these are all the drawbacks of using linked list. So this is the way we can use the linked list to implement stack. So hope you understand the concept. See you in the next one. Take care.